and welcome back. In this video, we're going to look at different types of biases and then review this chapter at the end. So as we talked about before, if you have a bad sample, it doesn't really give us much information about the population. So beware of bad sampling frames, right? That list of individuals from which you're going to take a sample. A simple random sample from an incomplete sampling frame introduces, of course, bias because the individuals included may differ from the ones not in the frame. Examples include people in prison, people dealing with homelessness, and long-term travelers, right? They're more difficult to track down and they're likely to be missed in phone calls, for example. Many survey designs suffer from what's called undercoverage. This occurs when some portion of the population is not sampled at all or has a smaller representation in the sample than it has in the population. Okay, an example of that could be like, let's say I had to do a survey and I was surveying students here during the times I teach face-to-face on campus, which is usually from 10 until about 2 o'clock. So if I do a survey of those students, my survey has undercoverage bias because I'm not taking into account the students that are there before 10 o'clock or after 2 o'clock. In addition to avoiding making mistakes when sampling, you should also be alert to some potential problems that can actually arise on their own. We have what's called non-response bias, and we kind of talked about voluntary response bias, right? And this is slightly different. And response bias. And you can probably figure out what both of them imply. A common and serious potential source of bias for most surveys actually is non-response bias for various reasons. People don't get the survey or they just choose not to respond, right? No survey is ever going to succeed in getting responses from everyone. The problem is that those who don't respond may differ from those who do, and they may differ in precisely the variables that we actually care about. So to combat this, it's better to design a smaller randomized survey, right? Random is the key, for which you have the resources to ensure a high response rate. Response bias, on the other hand, refers to anything in the survey design that influences the responses. Response biases include the tendency of respondents to tailor their responses to try to please the interviewer, the natural unwillingness of respondents to reveal personal facts or admit illegal or unapproved behavior, and the ways in which the wording of the questionnaire can influence responses. They may be very keen on answering the way they think the interviewer is wanting them to answer. And then, of course, that is big time bias, and we're not getting the results that are going to tell us anything about the population. How you should think about biases is look for biases in any survey you encounter. There's no way to recover from a bias sampling method or survey that asks biased questions, so keep that in mind. Spend your time and resources reducing bias. So think about the different sampling techniques we looked at, and also think about doing a pilot survey where it's a smaller survey giving to a smaller number of people in your sampling frame so you can test your survey and make sure that you're asking specific questions that are quantifiable. Think about the members of the population who could have been excluded from your study, right? You can have undercoverage there. If you can, pilot test your survey and always report your sampling methods in detail. You can read the problem here and pause it, and then there are questions continued on the next page to kind of wrap up what we talked about in this chapter. A company packaging snack foods maintains quality control by randomly selecting 10 cases from each day's production and weighing the bags. Then, inspectors open one randomly selected bag from each case and inspect the content. So that's a total of 10 bags. For this exercise, answer the questions for both the bags that are weighed and for the bags that are open for inspection. Okay, so what would be my population of interest here? Obviously interested in the quality of the bags. So my population of interest would be all, okay, so population refers to everyone, so all. So all snack food bags produced in a day by this packaging company. Okay, now I'm going to get more narrow. The population parameter of interest would be the weight of the bags, right? The proportion passing inspection. The sampling frame, remember, is the list. So you're not really going to have a list here. It would just be all the bags produced each day. So picture all the bags listed, right? That would be your frame. But we're not going to obviously sample each bag. Okay, what would be the sample? Obviously the 10 bags, right? Because they're randomly choosing the 10 cases, and then from each case they're picking a random bag. What about the sampling method? So what method are they doing here? Pretty much, I would think it's a random selection of the 10 cases, so it's more multi-stage. Because it's a random selection of the 10 cases, and then they're picking a bag from each of the cases. So you can think of the cases as like the clusters, right? Or even stratified. So it's a random selection of your 10 cases for which all bags are weighed. Is a cluster sample. Who, if anyone, was left out of the study? And there's really nothing left out here. Any potential sources of bias you can detect and any problems you see in generalizing to the population of interest. I would say both samples tend to be unbiased because it was done randomly. And that is the end of this video. That wraps up this chapter here. The next chapter, we're going to look at the difference between observational studies and experiments and what they entail. I hope you have a great rest of your day, everyone.